So today we're going to be taking our 4.2 notes, and our goal today will be to identify reflections in a plane. We'll have to identify relationships of reflections and perform a reflection on a coordinate plane. So a reflection, we actually already defined this in 4.1. As I told you, 4.1 was kind of an overview. We kind of looked at reflections and what they were. We did not get too much in detail with actually performing them and things like that, though. So we do know that it is a type of transformation. It was actually a type of an isometry, which we'll get there in a little bit too. So it's a type of transformation that uses a line as a mirror. The image is then reflected or flipped. The line of reflection is going to be the line the image flips over. That's kind of the mirror. So the line of reflection is the line the image flips over, or it's considered the mirror. A line of symmetry. Now I know you guys have talked about symmetry. This is a line a figure has if it can be mapped onto itself. A lot of you guys think about symmetry as if you could fold it in half. That's the same idea. So it's a line a figure has if the figure can be mapped onto itself by reflection, or if you can fold it in half. That's kind of the easier way to think about symmetry. So finding lines of symmetry. How many lines of symmetry does the figure have? So if you could imagine that there is a line down the center of this oval. We'll try to make them different colors so you can see. You could reflect this, and it would map over here, and this side would map over here. So that's one. You could also fold it or map the reflection this way. So there are two lines of symmetry. Be careful, because one of the things that a lot of people will do is they'll draw in their two lines, then they count them on the outside. They count 1, 2, 3, 4, and they think of that as 4. Maybe not so much with that one, but when you get more of the lines, that seems to be what happens. So this is a regular pentagon, meaning that all the angles and all the sides are all the same size. So this one, you could go through each of the points. So that would be 1. You could go through this point in the middle of the opposite side. This would be one of the lines. This point. So here we're at 3. Four. And the last point, 5. So the pentagon has 5 lines of symmetry. So if it's a regular polygon, it will more than likely have, it'll go through the side and then through each of the vertices, I should say, and the opposite side. Now, it doesn't work like that when there's an even number of sides, because if you went through a vertice, there's not really an it's going to go through another vertice. It's not going to go through the opposite side. So what happens then is when you get around to this vertice, you wouldn't be able to draw another line. However, you can draw a line, though, between the middle of opposite sides. Like that. So I'm going to go ahead and so something like this might be a little bit harder to count when you have that many different lines. So what you can do is you can kind of like check them off. So this is 1, 2, 3, 4, 5, 6, 7, 8. And when you get back to this one, you can see it's already the same as that one, so you don't count it. This one would be the same as that. So that way you can kind of, or even when you put the check mark, put an X here so you know to stop counting before you get to that one. So either way, this one has 8 lines of symmetry. And that's an octagon, which has 8 sides. So if it's a regular polygon, however many sides it has, that's how many lines of symmetry it's going to have. You'll just have to figure out how to draw those through. All right, example 2 says reflections in a coordinate plane. So, graph the given reflection. So if I start, let me grab a highlighter here. It says 3, 8 in the y-axis. So I'm going to plot 3, 8 here. Write 3 up. 8 would be right here, so I'm going to mark that J. Okay. And then it wants to reflect in the y-axis. So I'm just going to highlight my y-axis here. Now, to find J prime, you're going to go directly to the line and go in the opposite direction. Okay? It has to form a right angle with it because that's the shortest distance. So I wouldn't measure, like the reflection would be over here. It would be directly across. So this is 3 away that side. So we're going to go 3 away on this side. And that's where you're going to mark J prime. So because J is 3 units to the right of the y-axis, its reflection, J prime, is 3 units to the left of the y-axis. Graph and label J prime. We did that. So if J is here, J prime, we found, was at -3, 8. So this next one, it says, we're going to use the same graph, but we're going to have to kind of highlight and pay attention to other lines. It says K is at 7, 4. So let's go ahead and graph 7, 4. So 7, 4. It's right here, and that's going to be marked K. Now, the line X equals 7. Okay, graph and label K, we did that, and the line X equals 7. X equals 7 has to go through the x-axis at 7. Right there. Okay, so this is one of those special lines. This is a vertical line. So you will have to know how to graph lines other than just the y and the x-axis. So this is x equals 7. Now, because K is on the line, this implies that, so K is 0 away from the line. So we can't go, we could go 0 away in the other direction, but this is also going to be the place of K prime, because if it's on the line and you reflect over it, it stays in the same position. So K and K prime are the exact same point in that case. Okay, so if you flip it over, it says reflections in a coordinate plane. Use the pre-image A, B, and C. And we're going to use it in both of these. So we're going to kind of develop our rule of what's happening when we reflect in the x-axis versus what happens when we reflect in the y-axis. And these are rules that you're going to want to make sure you put on your cheat sheet for your test. They're actually, I'm going to tell you right now, they are questions on your test to fill in the rules. And then you'll want to be able to know how to use them on the actual test. So they are very important that we know these rules and we can follow them. So take a couple minutes. You can hit pause here and copy down the A, B, and C, plot them, and make sure you also write them down because then we're going to find them. Okay, so you should have all of this down already. So next it says that we're going to reflect in the x-axis. So what I want to do here is I want to highlight the x-axis. And if I'm reflecting in the x-axis, all I'm going to do is A is 2 above, so A prime is going to be 2 below, and I'm going to mark it. And then what I'm going to do is I'm going to write down A prime down here, because yes, it's easy to do it on the graph, but I want you to be able to identify the rule if you're not given a graph, because not every single time will you have to actually graph it. So A prime is at right 1, down 2, so 1, -2. Okay. Now B is right here. It's at 5 above, so we're going to go, it's 5 away from that pink line, so we're going to go 5 below. That's where B prime is going to be. So B prime is right 4, down 5. Okay. Now C is 0 away from the line, so C prime is also going to be 0 away from the line, and it's going to be right there on C. So C doesn't move, so C prime is at 5, 0 also. So I want you to take a look, and if 1, 2 goes to 1, negative 2, 4, 5 goes to 4, negative 5, 5, 0 goes to 5, 0, what is happening from the original, the pre-image, to these image points? What's changing? How is it changing? And we can also connect these points so we can see the triangle that's being reflected here. So what's changing in those points? If xy, we're going to write the rule now, if xy is reflected in the x-axis, which is what we just did, its image is, so your x value, 1 goes to 1, 4 goes to 4, 5 goes to 5, was the same every single time. So x, comma. Now notice 2 went to negative 2, 5 went to negative 5, but 0 stayed at 0. So what's happening with the y? It's becoming the opposite. The only time it didn't appear to be the opposite was from 0, but that's because the opposite of 0 is 0. So x comma negative y is our rule there. So xy goes to x negative y. So you can also write it that's kind of how you guys remember seeing the coordinate notation from yesterday, or from 4.1. So the next one we're going to do is reflection in the y-axis. So I'm going to highlight the y-axis here. Now, A is 1 to the right, so I'm going to go 1 to the left, and that's where A prime is going to be. B is 1, 2, 3, 4 to the right. We're going to move it 1, 2, 3, 4 to the left, and mark that B prime. C is 5 to the right. We're going to go 5 to the left, and mark that C prime. We'll connect all these so we can see that triangle and that reflection. So let's figure out where A prime is this time. It's at negative 1, comma 2. B prime is at negative 4, comma 5. And C prime is at negative 5, comma 0. So what is changing this time? X went from 1 to negative 1, 4 to negative 4, 5 to negative 5. So X is becoming opposite this time. So negative X, comma, what's happening with the Y's? Y is 2 goes to 2, 5 goes to 5, 0 goes to 0. So Y is staying the same this time. If you wanted to write it in coordinate notation, we would say that X, Y goes to negative X, comma, Y. Just like that. Now, the third rule. This line, Y equals X. That is that direct diagonal. So let me just show you really quick. I'm going to draw it out down here. Here is the coordinate plane, right there. That line, Y equals X, has a slope of 1, so it's going up 1, right 1, up 1, right 1, up 1, right 1, and it went through the origin because its y-intercept was at plus 0. Okay? So if you were to flip over that line, notice these two are going to switch spots. So if xy is reflected, that rule is going to be that x becomes y and y becomes x. So the coordinate notation rule here will say that xy becomes yx. So if you were to give it a point 1, 2, it'll become 2, 1. They just switched spots. And then our very last theorem says a reflection is an isometry. That's what we had mentioned at the very beginning of this lesson, that this was a type of isometry, and that is a theorem. So a reflection is an isometry. That is it for notes. If you flip it over, it just says, for the first section, determine whether the light figure maps onto the darker figure by a reflection in line M. Use the diagram at the right to complete the statement. So for this one, I wanted to specifically talk about this one because a lot of people will tell me that AB reflects to BC, and that's not the case. When you go to do this, what you need to do is draw in the segment, because a segment will reflect to a segment. Where does A reflect to? Over M, it goes to C. B is going to reflect on itself because it doesn't move. So when you do this, order is going to matter. It's very important that order matters there. So do it point by point, not over a whole image. Okay? You're just sketching the reflection, so you're just going to sketch a reflection for each of these. This one I know is going to go into your directions. That's okay. Find the coordinated, it's supposed to say find the coordinates of the reflection using the coordinate plane. Then check your answer by plotting the image and pre-image on this coordinate plane. So I don't care if you do the graphing first or second, but it does need to be done. And these ones are so you can use the rules and then plot both points, or you can use this, draw your graph in to find the new point. It does not matter. But you do need to know eventually how to do the rules. Sketch the figure if possible. So read that, see if it's possible, and try to sketch the image. 26 through 29. You do not have to graph these, but that's really going to help you because y equals 4 and y equals -2, x equals 2. These there are not direct rules for. You actually have to graph them, count the distance away, and then find the other one. Okay. Numbers 30 through 34, you're using this diagram. If you have any questions, let me know.